everyone, we're going to find a power series for the integral of x from x to 0 to x f t dt. Our function is f of x equals 2 divided by x minus 1. Now, looking at this, we're going to notice that this power series is centered at 3. And the way you do that is you look at x minus 3, set that to 0, so x equals 3. So our a is going to equal 3 when we do our integration. When you evaluate it, it's a lot easier if we're going from 3 to x instead of something else. So it's going to be a lot easier since it centers at 3. That gives us a 0 here. So let's go ahead and integrate both sides of the equation. So we're going to go from 3 to x. To save room, I'm going to erase that and write 2 divided by, our f of t is going to be t minus 1 dt equals, and we're integrating from 3 to x. And now we're going to expand this, starting with substituting in 0. So that's just going to give us 1 for the first term. When you substitute in 1, we're going to get minus 1 half t minus 3. And you substitute in 2, you're going to get plus 1 fourth t minus 3 squared minus 1 eighth t minus 3 cubed, and so on till we finally get to plus negative 1 half to the nth power, and then we're going to have t minus 3 to the nth power, dot, 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 and this is dt. All right, so let's go ahead and integrate this. For this piece, it's pretty easy. This is going to be 2 times ln of x of, t minus 1. And then we're going to evaluate this from x, 3 to x equals. Now, for this piece, we're going to get, for this, we're just going to get t. And then for the second piece, we're going to get minus 1 fourth t minus 3 squared. For this piece, we're going to get 1 12th times t minus 3 cubed. And for this piece, we're going to get minus 1 divided by 32 t minus 3 to the 4th. And then we're going to have plus dot, dot, dot. And finally, we're going to have negative 1 half to the nth power times t minus 3 to the n plus 1 divided by n plus 1 plus dot, dot, dot. Now, we're evaluating this. I'm going to do this from 3 to x. Now, notice on this second side. So, when you look at this, when you substitute into the 3, all of this is going to be 0 except for this first term. That's why it's centered around 3. I just want to point that out. So when I substitute in my 3, that's going to be 0. And we're going, because I have to do that, we're going to do it on the next slide. So on the next slide, what we're going to do is evaluate this. All right. So we're going to get 2 ln of absolute value of x minus 1 minus 2 ln of 2. Because you had a 3 here, so 3 minus 1 is 2. All right, so that was that part. Now the other side's going to be x. We're just substituting in x for everything at this point. X minus 3 minus 1 fourth x minus 3 squared plus 1 12th x minus 3 cubed minus 1 divided by 32, x minus 3 to the fourth, plus dot dot dot, and then we have plus negative 1/2 to the nth power. We have x minus 3 to the n plus 1 divided by n plus 1, and this is plus dot dot dot. All right, this part here, and I remember we're on a different slide. This part right here is from evaluating from 3 to x. So I just moved it up front here. It should really be back here, but I moved it there. Okay. Now, let's go ahead and simplify this. This is going to give me, I'm going to condense my logarithm here and write this as a single log. So since it's, I'm going to use my quotient property, so it's going to be 2 ln of absolute value of x minus 1, and we're dividing by this 2 equals, and now we're going to write this as the sum. The sum of n equals 0 to infinity, and we're just copying this down. So it's going to be negative 1/2 to the nth power, and then we're going to have x minus 3 to the n plus 1 power, all divided by n plus 1. So this is your answer. And don't forget, our interval of convergence was from 1 to 5. And that's it. Thank you. Have a nice day. Bye-bye.